We are not writing the program this week, so if you're behind and haven't finished up the 1.05 or 1.03 program, you still got time to get that done before I pile another one on top. We write a lot of programs in programming class. Go figure. Anyway, uh, we have a lesson we're going to look at today talking about numbers and using numbers in your program and data types, being able to identify what type of data you're using, whether it's a number or not a number, and if it is a number, what kind of number, because that's all going to be very useful next week when we do have a program to write. So you're going to want to uh, go through this lesson, pay attention to that, go to the Python guided activity, the practice that's in the lesson, and practice using these commands just so you understand them well. Go and change some things in the program that they have, just so you've got it, and you'll know exactly what you're doing next week when you get in there and start writing your own program. Remember, these Python guided activities are generally in every lesson, whether we have a program or not. And that's not the assignment. Those Python guided activities that's in the lesson is just using the commands you need for your assignments and showing you how to use them. But that is not, when we have a program assignment, it's separate. Sometimes there's some good stuff in that Python guide activity that you can kind of say, oh, well, that's what I need for my program. There's parts of it, but that's not the entire assignment, right? It'll just teach you how to do that. So we'll develop our programming skills to go along and just get better and better as the year goes around. And we will be doing some basic graphics before Christmas. So that's coming up. So we are starting. This is the beginning of the second half of the first semester because this is week 10. So we're going to get into more and more good stuff. So, but if you are behind, more get caught up. Behind me, you see this Friday is nothing. We have no school, fall break this week. We only have class Monday, Tuesday, Wednesday this week. So you've got a 4-day weekend. So if you're behind in this class, haven't got the test turned in or some of the programs, I would at least use Thursday to get caught up if you don't get caught up before Thursday, because you've got a double weekend coming and you want to enjoy that. You don't want to have to sit there and say, well, I'm going to spend my double weekend doing schoolwork. No, get it done before then. Get things knocked out. If you need help writing this program, I have class Wednesday morning. And some of you are already scheduled for RTI because you are missing those programs. So you should come in Wednesday saying, okay, Mr. Brock, I need help with this program. Here's what I got. Or I don't even know where to start. Or I'm having errors or whatever the situation is. Let's get that thing done by Wednesday so you can enjoy the 4 days stress free without something hanging over your head. So not so bad. You just got to pay attention to the details. You got to go through the lessons. You got to practice in those guided activities. So, all right. Well, let's get going. Oh, I did make it to a movie this weekend. I always like to have my movie chat. I saw Roofman. Roofman, based on a real story, interestingly enough, about a guy that would go in and he'd go in the middle of the night, back when McDonald's was not 24 hours. Most of them are all 24 hours now, but not all of them. Excuse me. But this was back in like the 80s or 90s. I think it was the 90s when this was based. And only the ones by the interstate were 24 hours. Generally, if you go in McDonald's, they were not 24 hours. And he would break into them in the middle of the night through the roof. He'd climb on top of them and he'd take his hammer and bash a hole in the roof, go in there and rob them. And he robbed like 49 of them and some Burger Kings. But he robbed a whole bunch of them. And then he was getting close, getting caught, and he hid inside of a Toys R Us. Inside the building, in the middle by the bicycles, there was this big display, this big thing that held up all the bicycles, and inside of it was hollow. So he climbed up inside of it, and he went and got it like an inflatable mattress off the shelves and everything, and he just lived there for months and months hiding from the police. It's meant to be a funny movie. It's a comedy. It's good. It's a great movie if you don't see all the previews, because the previews, unfortunately, this is one of them where the best parts of the movie are in the previews. All the funny parts. So I hate that when they give away all the good stuff in the previews. But it was a good movie, even having seen all the previews. So if you want to go see a good movie that's funny, Roofman is out there right now. Just came out Friday. So, and I hear the new Tron movie's good. I saw a friend at the movies, and they just come out of seeing Tron. They said, "Hey, good movie." There you go, Mr. Brock's movie chat for the week. All right, let's go to our grade screen as usual to get started. See where we're at. You should be done with everything in Module 1. We had the test a couple weeks ago. Last week we had processing numerical information, just 5 questions. This week we're going to add to that knowledge about getting numeric input. And then next week we'll have a program for the math module, and it will really combine everything we're learning in all 3 of these lessons. So you would make sure and practice and pay attention to the commands, practicing those guided activities, and let's learn about how to do some math in Python so you can write programs to do your homework for you. I guess that would be illegal if you wrote the program. Ask your math teacher, I guess. 2.02, getting numeric input. What's in a name? Well, that's what William Shakespeare once asked, right? What's in a name? Well, the literal answer is letters, all kind of strung together to form one name. You take a bunch of letters, you just kind of group. Yeah, that's what's in a name. Great question, Will. Appreciate that. But there's lots of other equally significant questions, like how many Oreos are left over? What's my age in dog years? Okay, I don't know if that's real relevant to anything. I think I'm about 7, 8, somewhere in that range. 8, 9. I don't know. So with Python, you could write a program to calculate and answer all of these burning questions. The key is just knowing which data type to use. So after completing this lesson, we're going to learn to distinguish the difference between integers, floating point numbers, and string values. That's the data types we're going to look at today. Integers, floating point, string. So we're going to figure out the differences. We're going to understand how computers store different data types in memory. We're going to talk about the integer and float functions to convert values, and the integer, float, and input functions to troubleshoot and solve math problems. So let's go to page 2, see what in the world we're talking about. Float, int, or string. Let's talk about floating point, integers, or strings. As you know, there's a difference between these 3 types of data, so let's compare them. So the first one we're looking at is a string value. So a string value is composed of letters or numbers that are not meant to be math, right? So a string could include numbers. It could be all numbers, but it's not any kind of numbers that you would ever use in a calculation. For example, a phone number, 800-374-1430, right? Your phone number, you can type that with all numbers. Don't put any dashes or parentheses in there. And it's just a string value. We don't ever add your number to somebody else's number to come up with a new number. We don't ever multiply or divide in numbers or anything. It's just a string value. So don't think of a string value of only letters, because it could be numbers. Just think of it as anything that you would not do math with. Hello world is a string value. If it says please enter your first name, that's a string value. Your address is a string value, right? Your zip code is a string value. Anything like that could have numbers, but we're not going to do any math with. And let's talk about the memory space that it uses. Well, it just depends. The amount of memory that a string takes up depends on how long your string is, right? The longer it is, the more memory it takes up. If your string is a whole chapter of a book, that's going to take up a lot of space, a lot of memory. If it's just one word, not much memory. Now let's look at the second type, a floating point. This is the float, and it's going to be the last one, the floating point. So a floating point is a numeric value. Numeric, think number. It's a number, either positive or negative, that contains a decimal point. That's the important part of the float. Floating point, decimal point, those go together. Floating point means it has a decimal point. Here's examples. 0.01, negative 1.3, 0.0. Since it's using the decimal, that's a floating point. The value of pi, definitely a floating point. This is a high memory space. It takes more space because the floats have decimals and they're more precise. So they take up a lot of memory, especially with pi. You're taking up, whew, I guess it could take up all your memory if you let it go. But it takes more memory to store decimal numbers than it does integers. An integer is a whole number that is either positive or negative, right? Like -2 or 88 or 0. Now, 0.0 is a float, but if we just use the 0, just the integer part, or the number of cookies you just ate, which could be a very large integer. So the memory space is low compared to float, especially. As relatively simple numbers, integers just don't take up that much room. Like 0 just takes up 1 byte, just 1 byte of space, where this would take up more than a byte because it's got to store the decimal and the other 0, even though it is a 0, it still has to store that in memory. So when writing programs, you got to keep in mind what type of data are you using. So if you're looking at a value, is it a floating point? Is it ever going to need a decimal? Is it an integer? It'll never need a decimal. Or is it a string, which means you're not going to do any math with it? It could be letters, it could be other symbols, it could be numbers, whatever. Luckily for everybody, here's an easy way. Follow this flow chart. Will I do any math? No, then it's a string. Even if it has numbers, right? Could be a zip code. I'm not going to do any math. It's a string. Maybe it's someone's name, Fred. Well, I'm not doing math with Fred, so it's a string. But if I am going to do math, then does it contain a decimal point? Yes, then it's a floating value. No, then it's an integer. What's this little thing here? Oh, that just breaks it out bigger, I guess. Oh, that just shows you that. Will I do math as value? No, it's a string. Yes, does it contain a decimal point? It's a float. It's an integer. So it's just the graphic, the text representation of this chart. Lots of values seem like numbers, but they're not floating points or integers. So think about your phone number, your driver's license number. You don't use those to perform math. They are strings. All right, so I'm going to open up the chat because we've got a little quiz here. Test your understanding of the differences between strings, integers, and floating point. So we're supposed to drag the following to the appropriate box. Is it an integer? Is it a floating value? Or is this a string? So the cost of an ice cream cone. So is the cost of an ice cream cone an integer, a float, or a string? Put that in the chat. Ali says that's a float. Most likely it's going to have a decimal point, right? Because no one prices their ice cream at $1. They price it at 99 cents because that sounds a lot cheaper than $1. Somehow in our mind, that penny makes a huge deal. So we're going to say cost of ice cream. Definitely going to be a float. How about the number of liters in a gallon? I guess the first thing is you have to think, do you know how many liters are in a gallon? Is it an integer? Is it a float value? Here's what I'm going to do. I'm going to go over here to Googly. And I'm going to say 1 gallon. Oh, there it is. 1 gallon to liters. How many liters are in a gallon? Oh, 1 gallon is 3.78541 liters. Now we know. I can do a camera count, or I can do a chat count that you're here participating. Number of liters is a float because we just looked at it. How about hello world? Hello world. Good job, Allison. Yeah, hello world's a string. There's not even any numbers in it. It's in quotes, so we're talking about the actual hello world thing. It is a string. How about P. Sherman 42 Wallaby Way? For those Finding Dory fans, P. Sherman 42 Wallaby Way. Yeah, that's the address, right? They're in Australia. In the movie Finding Dory, it's an address, so that is just a string. It's got a 42 in it, but it's not anything we ever do math. How about the number of points our basketball team scored? Is that going to be an integer, a float, or a string? The number of points that our basketball team scored. Well, it's not going to be a string because we might do some math with it. We might say, what's the total number of points our team scored this season? What's the average number of points we score per game? You know, there is lots of math you could do with a points. But is your team going to score 51.7 points? Are they ever going to score 60.3 points? No, the number of points your basketball team scores is going to be an integer, a whole number, no decimal needed ever. How about your telephone number? We actually talked about this one. That's a string value. We already mentioned that one. That's treat it like it's just letters because you're never going to do math with it. How about the results on a stopwatch? Maybe you get your little brother and say, all right, I'm going to time, see how long it takes you to go get me a glass of milk. All right, go. How fast can you make my bed? I'm going to time you. Go. Right, you get your little brother to do your chores if you make it a competition. Get him set a new record. Let's see. Last time he made my bed in 3 minutes and 40 seconds. Can you beat that? Yeah, that's a float value because it's going to be that decimal for sure. 8.342. Well, that's kind of a gimme, right? There is a decimal point, so it's a floating point number. It's a float. Good job, Nolan. 8. Is 8 an integer, a float, or a string value? Well, we assume it's going to be used in math, or could be. So 8 is an integer number. How about your social security number? It's got the word number right in it. Is your social security number? It's not going to fool Eiley. Says, I don't care if it's got the word number in it. It is a string value. The number of steps I walked today, which for me right now, it's early in the day. I'm at 619. Somehow I got credit for steps while I was sitting here, I think. Oh, no, I did get up and go get some breakfast. 619. Yeah, the steps is an integer. My watch will not count half a step. Total books in the Harry Potter series. See, isn't that 7.6? Is there 7.6 books in the Harry Potter series? Could be a string, could be an integer, depending on if we're counting.
What math would you do with a number of books?
Total number of books written by this author. Or
that's fair, yeah.
So I would probably put an integer. And they counted it as an integer here. Yeah. Because there could be some math you do just on that. How many books did this author write? How many books are counting the books in the series? It could be a math thing. All right, let's go to page 3. When to int and when to float. Okay. So let's say you got a part-time job. So you're working a few hours every week just to make a little extra cash. They're paying you $9 an hour. Python can help you figure out how much pay you got. So this is where the input function can really be useful. We used the input function in our last program. Write some code that prompts you to input your hours worked each week, and Python will tell you what your paycheck should look like. Well, if you can figure out all the taxes and stuff, this is just what you earn. But there's one snag. You have to tell Python the data type. By default, this is important. By default, that means if you don't tell Python anything, this is what Python's going to assume. Python assumes all the values that you enter with an input function are strings. Like we had to input in our last one, the chatbot program, like input, what is your name? Python's going to say, okay, that's a string. And if you use what was your name, that was a string. Because when you entered a name in there, my name is Douglas, that's a string value. And so Python assumes it's always a string value with an input. Strings are pretty useful, but you can't do any math with them. So the solution is you have to tell Python what it's working with when it's not a string. If it's a string, you don't have to tell it anything. But if it's not, we have to use either the int command or the float command in our code to let Python know, say, hey, this is an input, but make sure you treat this like an integer. We're going to do math with this, Python, so don't treat it like a string. I want to do math. It's an integer. So let's look how to assign things here. So here's a little program that Jenny wrote. So she worked from noon to 6 on Saturday. So her boss said, okay, make sure to put 6 hours on your time card and have a good weekend. So she wrote this Python program. Hours equals input, enter your hours. Rate equals $9. So she just saved that under a variable because if she gets a raise, she can just go change her rate right there. Then she figures out how much pay did she earn? Hours times the rate. And then she prints out her pay. So she wrote this little program where she can come home, run her program, just enter her hours, and Python tell her how much money she earned a day. So here it is. She's running it. She enters 6. Boom. What happens? She gets a type error. Can't multiply sequence by non-integer of type float on line 3. So what happened is when she typed in 6, Python said 6. Oh, it's thinking like SIX, right? It's a string. It's not a number, it's just a string. And then it gets to line 3. On line 3, it says, all right, take that string value and multiply it by 9.00, a float. And Python's like, I have no idea how to multiply a string by a float. It's like I'm multiplying Douglas by 2.5 or something. I don't know how to do that. He's going to come back with this error. So Jenny had to fix her code, and she did it like this. She went to her input statement right there at the top and said hours equals integer input enter hours. So around input enter hours, she put parentheses on both sides of it. In front of it, she put integer. Everything inside these parentheses, Python, treat this like a number. This is an integer. When I enter my hours, 6, that's a number, not a string. So then Python says, oh, okay, so multiply 6 times 9.00 and print that, it's 54.0. No problem. Python says, now that I understand that's an integer and not a string, I can do that. Here's your result. So now her buddy, Sheldon, he worked from noon to 6:15 on Saturday. So his boss said, okay, put 6.25 hours on your time card. Have a great weekend. Because he worked an extra 15 minutes, which is 1/4 of an hour, so 0.25. So he says, hey, let me see your program there, Jenny, and let me run that. So he ran the program, and he entered his 6.25 hours, and Python come back with an error. It says that's an invalid literal for integer with base 10, 6.25. Because when you enter 6.25, and we already told Python, hey, this is an integer, not a string, Python went 6.25 is not an integer. That's an error. I don't know what to do with it now because this is not an integer. So you had to go in and alter the code and change that integer to a float. Then when they entered 6.25, it said, oh, great, here, you earned $56.25. So it printed out 6.25 times 9. And it would still work if Jenny went back and typed her 6. It's okay. It would just give her 54.00 instead of just a 54. It's going to give her that anyway because the number she's multiplying it times is a float, 9.00. So you can enter an integer in a float value. You cannot enter a float in an integer. That's the big difference. All right, let's look at page 4. We got a Python guided activity here. So using int and float. So Jenny and Sheldon use special Python functions to convert their time to integers and floating point. These functions are super useful. So looking at how it works, here's like age. That's our variable that we're going to save this under. Age equals. And here's what we're going to store there under age. We have an input statement here that says, what year were you born? So when they run the program, the user of the program is going to type in a year. And we told Python, treat this as an integer. This is an integer. Because maybe we're going to calculate how old you are, right? We're going to take the current year, subtract the year you were born, and say you're this old. So that's going to be an integer. Because when you enter the year you're born, that never has a decimal. Maybe we have this one, GPA equals input. What is your GPA? Well, your GPA most of the time has a decimal. Oh, it's a 3.31. Well, that's a float. So we tell it, hey, this is not a string. This is a float value because we may end up calculating more of the GPA, adding to it, adding classes, recalculating the GPA. It's a float value. So here's our Python guided activity that we're going to go through and practice. And this is where you should go practice. So let's look at this code and see if we can figure out what's going to do. Hashtag numeric input. Define main, got our main function. This says, hey, this is an input. Num pizzas. So we have a variable we called num pizzas. We wrote it in camel case. 2 words, num pizzas. input how many pizzas do you want to buy. And then it says pizza cost is $15.50, 15.50. Calculate the total. Total cost equals the pizza cost times the number of pizzas. Well, that makes sense. 1550 times the number of pizzas. Then down here we'll print. You bought string num pizzas. Remember, if we try to print a string value and a number value together, Python freaks out and goes, I don't know how to print numbers and strings together. That's when we use this str command and say, I know it's a number, but just treat it like it's another string. And then Python thinks it's printing all strings, and it's very happy with that. This is where a lot of you are going to have an error next week in your program because you're going to forget when you concatenate, you have to treat numbers like strings, or Python kind of freaks out. You bought this number of pizzas. They cost this much each. Here's your total cost. All right, it says test your program with the input of 3. Run program. How many pizzas you want to buy? I'll take 3, please. Type error. You cannot multiply sequence by non-integer of type float on line 9. So line 9 is where it's calculating the cost. And it has the pizza cost right here, which is a float value. And the num pizzas, which is up here, which it assumes is a string because we didn't say it wasn't. Remember, the default is this is a string. It's going, so I've got this word and you want me to multiply it by 15.5. I don't know how to do that. So to fix that, we should go in here and say, all right, the number of pizzas I want is going to be an integer. So I'll put this in parentheses, put the whole thing in parentheses, and in front of the parentheses, I'm going to say this is an integer, int. And now everything in here, Python's going to say, oh, that's an integer. Okay. So this time, let's see how many people get here. Oh, it's like 30 students. I'll probably get like 6 pizzas now. We're going to get a lot more pizzas there. 6 pizzas. $93. See, it worked fine. You bought 6 pizzas. They're $15.50 each. That's $93. That's right. It's on me, guys. I got it. So fixing that with the integer, because we're not going to buy 2.5 pizzas, right? It's not sold by the slice here or anything. It's 2.5 integer. All right, let's look at the second slide. Input num pizzas equal integer. How many pizzas you want to buy? Pizza cost. This time we're asking them how much do they cost instead of just having the cost, because there may be different sizes. So which one do you want? Calculate. Still calculating, still printing the same stuff. Nothing changes. The only thing that happened here is how many pizzas you want to buy. What's the total cost? I mean, what's the cost of each one? So when we run this and say, okay, I'm going to buy 5 pizzas, and they are $19.99. I got to get the really big ones because there's a bunch of us. Get the extra large pizzas. Oh wow, you bought 5 pizzas. They're $19.99, and look, your total is 19.9919.9919.9919.9919.99. I don't know how much money that is. There's way too many decimals. It didn't create an error, not a runtime error. Like it didn't stop the program. It just went ahead and did some math and gave us this really weird looking number. What did it do? Well, it said, this is an integer. This, we did not tell it. So it said, this is a string. So what did it do? It printed 1999, and then it printed 1999, and then it printed another 1999. And I mean, we might as well have said, how many pizzas you want? I want 6. And what's the cost of the pizza? Douglas. Your total is Douglas, 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 Douglas. See, it's just printing the string 6 times because that's what I told it to do. This is an integer, and I guess this is a string because I didn't tell it any different. So it says, okay, I guess you want the string 6 times. Not what this is a logic error. It's an error, but it's not anything that stops the program from running, but it does not produce what we expected it to produce. So if we go back here and say, wait, this is a float, parentheses, parentheses. Okay, treat this like a float value then. Let's say, okay, I want 5 pizzas. They're $19.99 each. Great, $99.95. That works. Now when it multiplies an integer times a float, it gives me a float value, which is fine, and it can do the math. So a string times a float is an error. An integer times a float, an integer times a string, it'll just repeat your string how many times you told it to. And an integer times a float produces a float. All right, one more slide here. Input num pizzas, integer input, how many you want, pizza cost, float, which was cost. So let's try adding a $5.50 coupon. So add code that asks the user for the value of the coupon and then calculate the new cost. In the output, include the value of the coupon. And they want us to test it with the numbers 3, $8.99, and $5.50. All right, so we already have the coupon in the printout. The coupon is string coupon. So there's the name of our variable. But we just have to go up here and ask how much. Coupon equals, since the coupon's $5.50, we know it's going to be a float. Input, how much is your coupon? All right, you don't have to put a space between these parentheses unless you just want to. They did just to make it easy to see. There's 2 of them, but we have 2 opening parentheses, so we need 2 closing parentheses. We also have to subtract that from our cost. Pizza cost times number of pizzas minus the coupon. All right, and it's already going to print it out. So let's see how this works. 3 pizzas, $8.99, plus I've got a $5.50 coupon. 3, $8.99, $5.50, $21.47. Because these are like $9 each, so it'd be like $27, but instead it's $21.47. So it'd be $26.97. Subtract $5.50. $21.47. If we want to make sure it's working, we can test it with some different numbers. I want to buy 3 pizzas. They cost $10 each, not $100. And I've got a great coupon, $29.95 off. So I'm paying a nickel, but just testing my program, throwing different numbers out there to make sure it does what I think it's doing. It does take 3 pizzas at $10 and subtract the $29.95. So I'll pay a nickel for those 3 pizzas. But you can come in here and play with this. You can change some of the code. You can put in different numbers. You could create something totally different, another input, and calculate something else in there. Like you could say, do you want any beverages? How much you want? How many drinks do you want? How many 2 liters you want? And add that into your total cost. Play with it. See what you can do. All right, that is the end of the lesson. It says read the lesson, practice on that Python guide activity I was just playing with, and then let's do the quiz. Let's look at our quiz. When asking the user for input of a numeric value that's negative and has a decimal, which one of these are we going to use? Which function is used to convert a string value to a numeric value with a decimal? Which one of these is going to use? This has an error. What function do we need to add? This has an error. Which function here do we need to add? Because floating points have decimals, they're more precise and take up more memory. Is that true or false? All right, there you go, guys. I've seen some students have a question that asks them about concatenation. What do you need to use to concatenate? Because like I said, we'll not print a string and a number together. You try to print your total is plus quote, don't quote total, like total is a variable that we calculated. It'll give an error because it's trying to print your total is, which is a string, and your total, which is a number, and it can't do that unless you use that str command. That's why I said you're going to have trouble in your program next week if you forget that. To say, I know this is a number, treat it like a string. Your total is total, and it'll treat it like it's a string. So, all right, guys, that's your assignment this week. You've got the 5-question quiz. Next week, we will be writing a program doing some math. So we'll be using the integer and the float and the string for concatenation. So, practice with this, get familiar with it. If you didn't understand last week's, go back and review that. got questions to ask. But if you're missing any programs, come see me Wednesday. We don't have Friday this week at all. No school Thursday or Friday. But let's get caught up on anything you're behind because we're halfway through the semester. Let's get a fresh start going forward. So. All right, guys, I'll give you the rest of the time yourself. I got the programming 2 students coming in here in just a couple of minutes. So have a great day. If you got any questions, hang around. I got a minute or two. But otherwise, go tackle your week.